When you boil water in an open pot, you lose massive amounts of thermal energy as steam escapes into the air. A pressure cooker solves this by creating an airtight seal. Standard atmospheric pressure, water boils at exactly 100 degrees Celsius and cannot get any hotter. But as trapped steam builds internal pressure to the optimal working pressure of 1.0 to 1.2 kilograms per square centimeter, the boiling point is physically forced up to approximately 120 degrees Celsius. That 20-degree shift is the core mechanism of the appliance, allowing the water to carry more heat and cook food faster than standard boiling. Maintaining a 120-degree pressurized environment requires constant mechanical regulation to prevent structural failure. The primary control is the pressure weight on the lid, which lifts to vent steam and sustain working pressure. If it fails, a mechanical safety valve engages to release steam before safe limits are exceeded. As the ultimate failsafe for maximum safe pressure at 2.5 kilograms per square centimeter, a fusible alloy safety plug is designed to melt and vent steam if temperatures spike. This tiered, passive mechanical system balances these pressure extremes, allowing the cooker to operate safely without manual intervention. The complete process functions in a predictable sequence. Heat boils water, the seal traps steam, pressure rises, and internal heat intensifies. Because the vessel remains airtight throughout the process, nutrients and flavors that would typically escape with the steam are instead held within the pot and the food. By engineering an environment of artificial high pressure, this system applies the heat required to cook food thoroughly in a fraction of the usual time.